Here we're going to take a close look at the hem tool found in SOLIDWORKS Sheet Metal and how it can be used to very easily add these metalworking processes to your parts. The hem tool is used to fold over edges of a sheet metal part, and in SOLIDWORKS there are 4 types of hems or folds that are available to you, and these are closed, open, teardrop, and rolled. The hem tool can be found here in the sheet metal ribbon. So I'll click it to access the property manager. And here's where I put in all the information I need to create the hem that I want. I need to define the hem type, the hem size, as well as the edge which I want to fold over. So let's start off here with a hem that's 3/16 of an inch long, and I'll apply it to this edge here. As you can see, it sort of crushes the material flat against itself. This is sometimes called a Dutch fold. So now let's take a look at a similar hem, the open hem. This is just like the closed hem in that it folds over a certain length. However, the open hem adds a radius. For this case, let's add a radius of, say, 50 mils, but we'll keep the length the same at 3/16 of an inch. And here's that spacing that I was talking about, added to the hem because of the radius. So now let's move on to some of the more fun types of hems, the rolled and teardrop hems. First, let's look at the teardrop type. I'll define the angle for the hem as 225 degrees and a radius of 1/16 of an inch. And let's apply it to this edge here. Now essentially what SOLIDWORKS is doing for this is rolling the edge out a certain radius and angle, but then it's extending it back to the original flange. This is a very easy way to create an edge flange that extends past 180 degrees. Finally, let's take a look at the rolled type of hem. For this, I'll use an angle of 295 degrees and a radius of 50 thousandths of an inch. So let's apply it to this last edge down here. And there you have it, the 4th type of hem, the rolled edge. And so far, we've only applied hems to edges that are straight. But what about circular edges, like this hole that we have here in the center? Well, you can even add hems to these types of edges as well. For this, we're going to represent a process known as coining by adding an open hem to this circular edge here. And let's take a closer look at this. Using a section view, you can see the new hem added to this hole. So using the hem feature, I hope you see you can easily add this very important process of hemming to your sheet metal parts. You're in control of the shape, size, as well as direction, like inside or outside of the hem. But you're also in control of the portion of the edge to apply the hem to. What I mean by that is, instead of the default entire length of the edge being hemmed, you can change this by selecting this option here so you can edit the hem width. With this option, you can now adjust the size and position of the hemmed edge just like you would any other sketch line. And the last thing we're going to look at is the option to add material inside or outside. Now this does not define the direction of the hem. That's simply done by reversing the direction, just like you would an extrude. When you toggle between the option for material inside or material outside, what you're really doing is defining this new hem in relation to the original edge. If you check material inside, then the hem will extend only as far as the original edge. You can think of this as making the new face tangent to the original edge. In other words, all of the material that gets added will lie within the edge of the original flange. Now when you check material outside, you're defining the starting point for the hem. The original edge flange will be maintained, but the new hem will be added to this flange. All of the hem material will be added outside of the original edge. And here you can see as I toggle between from material inside to material outside what's really going on.